Hello everyone, welcome to Data Discovery. At this video, we are going to see the concept related to kernel density estimation. It's nothing but KD. So, as we have coming across the statistical distribution like PDF, PMF, CDF, all the probability density function we have coming across it. So, based on that, the kernel density estimation we are going to discuss. So, this all are the basics related to PDF, PMF, and CDF. I hope that video you have got it. Okay, if you haven't checked, then go to the description box, you will be getting my link. Okay, so that will be the basics for the kernel density estimation. So over here, the kernel. Okay, first of all, we'll just understand the kernel and density estimation and exact concept related to it. So the kernel, it's nothing but probability distribution function. So it's nothing but probability distribution function. Okay, related to probability distribution function, we have came across like in the x-axis you will be getting some of the values, any values you can say, and over here it's all the probability values you will be getting. Like if you have 1 2 3 4 any value, then what is the probability of that particular range from 0 to 1? What is that probability? Okay, that we can identify by using the histogram graph, and then after we will be plotting in which you can understand what the distribution that the particular data it's following. So based on that, we have came across later probability distribution function. So what is this density estimation? Okay, first let's understand what is density estimation. It is a statistical technique. Okay, it's used to estimate the probability density function. Used to estimate the probability density function called PDF of a random variable based on the set of observation or data. Yeah. Okay, we are finding based on our data. So over in the estimation, density estimation, we are having two groups. One is of parametric density estimation, and another one is non-parametric density estimation. So there are two different types of the density estimation: parametric density estimation and non-parametric density estimation. So what is this parametric and what is this non-parametric? Once we have came across it, then after we will be moving to the kernel density estimation. I hope later to kernel you got the concept what is this probability distribution function. Okay, I'll just give a one small recap of the PDF, PMF, and CDF. Okay, and then after what is parametric density estimation, non-parametric, and then after once we have cleared it off, if we will be moving to the KD, then a complete concept will be clear. So let's get started. As we have gone through this PDF, that is nothing but probability density function. So what is this PDF? Okay, it describes the probability distribution of the continuous random variable. So there are two random variable, two different types of the random variable. One is of discrete and one is of continuous. The PMF, probability mass function, suppose the discrete random variable, and the PDF suppose the continuous random variable. Okay, it means in the y-axis that whatever we are having, it contains the probability density. For example, here some of the values is there from 0 1 2 3. Okay, 0 1 2 3 4. Okay, and over here all the probability values, point 0.1, point 0.2, anything values. Okay, so if I need to find, if the distribution is something like this, the distribution is something like this. Okay, if I need to find the area between the range 2 and 3, so if I need to find it, if I need to find the area of it, so by using the probability density function we can easily find it, like 2 to x to 3. So what will be the value of the probability? So between 2 to 3, what will be the probability that we can find it through PDF? So by using a area, by using a integration, we will be doing it. We will be creating one function, and then after we will be giving a limit from 2 to 3, and we will be getting the exact the probability of the particular range we can get it. Okay, this what the PDF says. So what is the meaning of the parametric and non-parametric? That will just move on to it. Parametric, it's nothing but if there is certain kind of the distribution. Okay, there are many kind of distribution: log normal, normal distribution, Pareto distribution, Bernoulli binomial. There are certain distribution in which there are certain names for it, but there are distribution in which we couldn't able to get what the actual distribution is, something like this. Okay, this, there is not any particular name for it. Okay, if there is a log normal distribution, Pareto distribution, okay, each and every distribution describe the data, what the data says. Okay, I'll just give one example. Like I'm having one distribution in which it's the data is related to salary. Okay, so salary from this will be my 10K, 20K, 30, 40, 50, 60. Okay, in India I'm just giving the distribution of these salaries. So the distribution is something like this. Okay, so in the distribution I can identify that in between 30 to 40, the max to max people, okay, there are a large number of people who are falling in the group in 30 to 40. There are less number of people who's having the salary more than 60 but having very less number of quantity. So by using a y-axis you can say that there are very less number of quantities of the people who are having more than 60 or more than 50 salaries as compared to 30 to 40. So by using a data you can describe what type of the data it's saying, what type of the story it's saying. So same thing happens over here also in a data science stream also it happens. So based on the data what actually it says, so based on that we used to plot different types of the distribution, and based on that we can identify it. So the parametric distribution, it's nothing but the distribution in which we know that what type of the distribution it already exists. It's nothing but it's a method of estimating the probability density function of a random variable by assuming that the underlying distribution belongs to a specific parametric family of the probability distribution, such as normal distribution, axial distribution, log normal, Pareto distribution, in which the distribution already exists. Okay, but in non-parametric, that whatever I have drawn it over here, the distribution it's not clear, or it's not one of the famous distribution. It is a statistical technique used to estimate the probability density function of a random variable. Okay, over here also by using a probability density function y-axis we are having a probability density function. By using that only we are plotting the graph. Okay, without making an assumption of the underlying distribution. Over here there is not any assumption for the underlying distribution. It is also referred as a non-parametric density estimation because it does not require the use of the predefined probability distribution function. So the non-parametric density estimation techniques involves the constructing an estimation of the PDF, the probability density function, using the available data. Okay, this is typically done by using a KDE. So by the non-parametric density estimation, okay, the KD comes into the picture. So why the KD we are using it? So it's because of non-parametric density estimation, in which there is not the particular plot exist. Okay, in which it's nothing but the smoothing of graph, but still. Okay, by using the histogram we are just smoothing it. So how this bimodal function, okay, comes it off. Okay, by using that we will be constructing from basics from the histogram, and how it's we are smoothing into a graph that we will be discussing step by step. Okay, in this video itself. Okay, but the KD is nothing but a non-parametric method. It's to estimate the PDF of a random variable based on kernels as weight. So based on the kernels. So based on kernel's way that we are going to discuss over here. So now I'll just practically explain it, and then after we will be moving to the code. As we have gone through the parametric distribution and non-parametric distribution, in which due to non-parametric distribution, in which the distribution doesn't exist. Okay, like a normal distribution, Pareto distribution, log normal distribution, it already exists. But this type of the distribution, the bimodal distribution, doesn't exist. So how the plot comes into the picture, and actually this type of the data usually we used to see in our real-time project. So each and every data, the distribution that we can say, it will be not like a normal, or it will be not a named distribution, already inbuilt distribution. It doesn't occur at every moment. So there will be a major almost 85 percentage of our data usually comes in this type of the distribution only. So we need to deal with it. So for that purpose this KD comes to the picture, and that's what we are learning it. So whenever whatever the things that we are learning in our complete in our videos and our YouTube videos etc thing, we need to know that why we are learning it. So at that moment we can understand it very easily. Okay, so let's start with it. So over here I got one good image. So based on that I'll just explain with it. Okay, this is nothing but a normal histogram graph. Okay, a normal histogram graph. Okay, over here in x-axis the range of the x values is nothing but the input values, you can say around 4 5 6 6 values is there. Okay, I'll just draw it over here, it's already inbuilt. After the what will be the KD plot, they have already completed with it, but how they have done with it, so I will be explaining it over here. Okay, and this y-axis is nothing but the probability density function, all the density values. Okay, so let's get started with it. Whatever the values is there, so as I've said around six values is there, so around six data points. Okay, so around for six data points. So by using the histogram graph you can understand the outlier also, like there will be certain kind of the distribution, like it will follow in this manner, and one distribution only one data point is following over here, so you can understand that this is an outlier. So over here some kind of normal distribution it's following, but because of that the normal distribution affects. So you can understand how the outliers can be find it out by the histogram over here we can see. Okay, so for every data point, okay, note it, for every data point the mean will be different. As per the data the mean will be different. Okay, so based on it what we are doing, we are doing a normal distribution. Normal distribution is constructed by the mu and sigma. Mu is nothing but mean and sigma is nothing but the standard deviation. So for every data point, okay, whatever it's driving, as I've said six, I'll just draw it over here. One, two, three, four it at one side, and five and six is the other side. Okay, so now for every data point there will be a certain mean, and in y-axis is nothing but my density. So it's nothing but we'll just represent as d. Okay, for every data point whatever it's happening over here, just calculate the mean, and based on it, by calculating a mean, based on it you need to draw a normal distribution. So a normal distribution, it's always centered on the average value. Yes, so we will be coming across this normal distribution, standard normal distribution etc things in our coming videos, but just understand how the plot comes into the picture, that we need to understand. So for every data point over here, for this, I hope this is quite blur. For this, calculate the mean, it's nothing but the calculate the average value. So based on that, draw a normal distribution. You have complete with it, so it's not looking like a normal distribution. Okay, so now the second data point over here. Okay, for this also calculate the average value, that is nothing but the calculate the mean and draw a normal distribution. You have done with it. Third data point, for every data point you need to calculate the mean and you need to draw a normal distribution. Okay, four distribution is quite away than the first three, so because of that you can see first, second, third and fourth is quite away, so because of that it's coming away than the first three. Okay, and the fourth and the fifth and sixth, okay, it's away from the first four over here. Okay, you have done with it. Once you're completed with the plot, now what we need to do, like I will be explaining over here. So over here we will be drawing it like that. Okay, and once the picture, like one data point, two data point, three data point, it just coming together, right? So at that moment you need to add it. So if you will add it, then definitely the density will be high. Over here 3 point is there. For that, the point will be comparatively high. And next over here 2 point is there. So already it came till here. For the first 3 point, it when we are comparing, when we are adding it, so at that moment it's coming over here, and then after 2 points is coming, right? So at that moment a quite low point. So same thing for every next data point, you need to add it. Like over here you need to add it. So at that moment you will be getting some higher plot, like over here 1 2 3. Okay, so at that moment you need to sharpen the data, sharpen your plot. And once it comes lower, like over here only one data point matches. Okay, so over here 1 2 only two. So at that moment you need to come little bit low. And then after only one data point at the time. Okay, over here one data point, so little bit more low, and then it just going down. So by summing up the values, by summing up the previous plot, like whatever the normal distribution that you have plotted it, just add the data point whenever you're getting the sum of the values. Like over here is joining 2, over here is joining 3. So at that moment you need to sharpen your plot. Okay, got, like if 1 2 3. So at that moment how many data points touching? 1 2. So you need to add 2 point. Now one data point only, so take it down, and next it just going on. So this is how the plot comes. So this is how we need to draw it. I hope from this picture you got the clear how we need to draw it with the KD plot. So this is nothing but about the kernel density estimation. So by understanding the parametric distribution, like parametric and non-parametric concept, I hope this concept got clear. Anyways, we will be starting with the coding part, but before that, some small concept related to standard deviation that I need to clear, so that the part I need to you need to understand. Like uh, you will be getting some kind of the normal distribution in this plot, in this type also, like this. Okay, something like this. So this flattened areas, like over here, this bandwidth that we can say. Okay, this values differs, right? For this the standard deviation will be different, and for this the standard deviation will be different. Like the mean might be same. Okay, the mean might be same, but the standard deviation for this plot and for this plot it may differs. Like over here the standard deviation is quite low, and for this the standard deviation is quite high. So more the standard deviation, more the dispersed plot you can get it. So less number of standard deviation, the less number of dispersed plot you can get it. Okay, so based on that plot distribution, like over here if your the distribution, if your normal distribution is quite dispersed, so at that moment your KD plot also will be quite in the part of the smoothening form. Okay, and like that it will be, it's almost in this format. So this is how your KD plot looks at that moment. Like over here one data point matching off, so over here it came up, and then after no other plot came inside it. Then after two plot, so for that the again the hump came, and then after you're getting it. So this type of the distribution comes by the mean and standard deviation. So more the dispersed plot, the bandwidth is quite more, so you will be getting in the more dispersed way. So this is the something related to KD. Now we'll just move to the code, that how we need to express in the Python code. So let's start with the coding part. I have already built the notebook for the KD. Okay, over here I have imported the data in the random format, but I have used the seed thing. So because of that, I can get the constant value at every plot. So if you're using the same data, like if you're importing the random.random 100, but if you're using the seed as 42 only, so you will be getting the same data itself. But if the seed is different, the distribution will be also different. Okay, so if I will be not using the seed, so again in different times, if I will be running the data, I will be getting a different data. So because of that, I kept a seed random seed. By using a random seed, I kept it the constant format. Okay, so I have used the data. Okay, I have imported some of the libraries and matplotlib, cbond for visualization tool, and for pandas for the file that whatever that I'm using, and numpy to convert into an array format. Okay, over here, first let's plot the histogram. So for that, the bins and bin size it's needed. So bins, that how much you need, the user need is based on it. Okay, you can able to hypertune it. For that purpose I have written over here. But based on your bins only, the bin size will be calculated. So it's nothing but the maximum value minus minimum value by number of bins that have been selected. So based on it, we can plot the histogram. So by using that, I got this all bins. Okay, this all are the bins. Okay, so this is nothing but the Gaussian normal distribution, the formula. Okay, we will be coming across the Gaussian. What is this normal distribution all? But we this formula is well known, right? It's nothing but 1 by sigma by root 2 pi e raised to minus 1 by 2 x minus mu my sigma the whole square. So the normal distribution is completely built by the mu and sigma. So based on that, I have just used this function. Okay, in which the for to build a normal distribution, like as I have shown it over here, like for every distribution, for every bins, that is nothing but for every values, we have found the normal distribution. Okay, and then after the smoothing begins. So first we need to build the normal distribution graph. Okay, and then after, like over here I have done for every the data point, like it's nothing but minus 2.61, it's nothing but my first value, minus 2 6 point minus 2.6197. Okay, and over here minus 2.3961. Okay, so if the plot is not clear, so you just reduce the data point. Like over here I have used the 100, so based on that I have used the bins as 20. So you can reduce it, and so that the plot will be clear. Okay, so for every distribution, first we need to do draw a normal distribution for it. So I have done with it. So after completing with it, you need to do with it uh, KD plot. So for that, what you will be doing, you will be adding the particular all the data point. Like over here, almost every data point is matching. So because of that, the plot just almost it's same, right? So because of that, the plot will be also like a normal distribution only. Yeah. Okay. It's almost normal distribution. Like over here in X, you can see it's like 0, 1, 2, 3. It's nothing but it's converted into a standard normal distribution. Like mu is equal to 0 and sigma is equal to 1. Okay, so because of that, the x is like 0, 1, 2, 3. And you can see the by drawing a KD plot, like previously we have seen there are certain outliers. So because of that, you got the bimodal distribution. But over here it will be almost a normal distribution only, because each and every data point is matching with some of the other point, it correlated with some other point. So because of that, the plot will be almost like a normal distribution. So this is nothing but related to KD plot, like how we need to draw it. As over here we have first converted, first we have used the data in which you have done with the the histogram plot, the bins and bin size, and then after you have defined the function called as a normal distribution, you have used it, and so for every data point you have built the normal distribution over here. And then after you have converted it into a KD plot by summing up the values of density, and based on that you have plotted it. Okay, so this all are the procedure that you will be not using completely for any project. Okay, that is a KD library itself do the smoothing of graph just in one line. So this is how the actual things work it off. So for that I have shown it over here. So this video was related to a kernel density estimation. I hope this video find it up so useful. Do like, share, and subscribe to the data discovery. I will be coming more related to data science, data analysis, in number of videos in this channel. Thank you.